Hi, my name is Jeremiah, and this is my group's presentation on optimizing resource usage in a finite world, focusing on current sustainability challenges and the role engineers play in improving system efficiency. Resource depletion and environmental impact are increasing global concerns, as human consumption now exceeds the Earth's ability to regenerate resources. This imbalance leads to environmental degradation, loss of biodiversity, and climate change. As engineers, it is important to focus on improving efficiency, reducing waste, and developing more sustainable systems. Resource consumption is driven by population growth, economic development, and the expansion of agriculture, which increases global demand for materials, water, and energy. Projections show that the material use will rise significantly by 2050, alongside increases in water withdrawal and fossil fuel consumption. This graph illustrates how this demand is steadily grown and is expected to continue increasing. Many current systems are inefficient due to poor design and lack of environmental awareness. For example, buildings account for a large portion of the global energy use and emissions, yet efficiency improvements are minimal. This results in significant energy losses, excessive resource consumption, and a continuous increase in demand. The core issue is that the global resource consumption exceeds the Earth's production capacity, largely due to inefficient systems for extracting, using, and disposing of resources. This makes current practices unsustainable and contributes to long-term environmental instability.
Solution 1: Energy and Resource Monitoring. For our first solution, we looked at energy and resource monitoring. This means using things like smart meters, sensors, and data systems to track how energy is being used in real time. The reason this matters is because a lot of systems waste energy without people even noticing it. By collecting live data, engineers can see where energy is being overused and then make changes to fix it. For example, it can reduce unnecessary heating, cooling, or lighting in buildings. In the report, this was the strongest solution because it was practical and easy to apply to existing systems and can improve efficiency without having to rebuild everything. Solution 2: Designing for Efficiency. Our second solution is designing for efficiency. This focuses on making systems better for the beginning so they use less energy and fewer materials. Instead of waiting until a problem happens, this solution tries to prevent waste right away through better design. Some examples are improving insulation, using LED lighting, and making systems work in a more organized and efficient way. This is important because it lowers resource use at the source. It may take more time and planning to put into place, but it can create a strong long-term improvement and works well along monitoring systems. Solution 3: Renewable energy and sustainable materials. Our third solution is using renewable energy and more sustainable materials. This helps reduce dependence on non-renewable resources like fossil fuels, which are limited and also harmful to the environment. Renewable energy sources like solar, wind, and hydro can provide cleaner energy with lower greenhouse gas emissions. Sustainable materials can also help because they can lower the amount of energy needed for production and reduce waste over time. This solution is very important for long-term sustainability, but compared to the first solution, it can be harder to apply quickly because it often needs bigger systems, changes, and more infrastructure.
For more findings, the energy and resource consumption monitoring systems play a significant role in improving overall sustainability. One of the key results that we found in these systems is that they can reduce energy consumption in buildings by approximately 20 to 25%. And this is mainly achieved by identifying the inefficiencies in real time, such as the unnecessary heating, cooling, or lighting usages. What makes this especially important for us is the ability to make data-driven decisions. Instead of relying solely on assumptions about how a system is performing, we can use actual data to detect these patterns, identify energy losses, and optimize performances. And this overall can lead us to a more efficient system design and operation as well. Another important point to take note of is the scalability. These monitoring systems are not limited to just one type of building or application. They can be implemented in residential buildings, commercial infrastructure, or even large-scale systems as well. This makes them a practical solution that can be applied broadly without requiring a complete redesign of the systems we already have. In relation to engineering as a whole, this highlights the modern shift towards more smarter and more integrated systems. Modern engineering is not just about designing structures, but also continuously improving for what we have using feedback and data. These monitoring systems allow us to bridge the gap between the design and the real world into a better performance. However, it is important to recognize some limitations. These systems do not automatically reduce energy consumption on their own. Their effectiveness depends on how the data is interpreted and whether the appropriate actions are taken. There are also initial costs associated with installing these, specifically for the sensors and the data systems, which may limit their adoption in some of our cases. But overall, the results show that these energy monitoring systems are a practical and effective approach to improving our overall sustainability. It demonstrates how in engineering solutions for our solutions, they can be used not to only design systems, but also actively and optimize them over time. I believe that makes it a strong candidate for addressing the current sustainability challenges that we have.
To conclude, the main problem is that people are using resources faster than the Earth can replace them. This is happening because many current systems are inefficient and depend too much on finite resources. In the report, we looked at three solutions: energy and resource monitoring, designing for efficiency, and renewable energy with sustainable materials. All three can help improve sustainability in different ways. Out of the three, energy and resource monitoring stood out as the most practical solution right now because it is easier to apply and can give immediate results. At the same time, real long term changes will need a combination of all three solutions working together.